Stop worrying about homework and start learning with confidence. This is Ask Learn. Complete help for every subject. Like, share, subscribe for daily learning videos.
Hello. In this problem, what we have is an electron headed vertically uh, through a horizontal magnetic field. So what does that look like? If we draw our ground like this, we would have a magnetic field that is horizontal. We will represent it as a blue line. Here we have our vector magnetic field. And then we also have our electron. We'll represent it as a dot and a little symbol E, and it's headed completely vertically upward at a particular velocity. Now, the question is, what is the acceleration that this electron feels due to this magnetic field? Well, first, we're going to have to find the force that the electron is feeling from this magnetic field. Now, the magnitude of that force is given by the magnitude of the charge traveling through the magnetic field, the velocity, the magnitude of the velocity that the charge is traveling with, or the speed of the charge, the magnitude of the field through which the charge travels, and the angle, the sign of the angle between the two velocity and magnetic field vectors. Now, we have all the information we need to solve for the magnitude of this force. The magnitude of the charge of an electron is 1.6 times 10 to the negative 19 coulombs. The velocity of the electron is given as 2.1 times 10 to the 6 meters per second. The magnetic field is given by 1.6 times 10 to the negative 5 teslas, the SI unit for magnetic field. And now we just have to look at what is the angle between our velocity vector and magnetic field vector. Now remember, we can translate vectors wherever we want, and how we figure out that angle is we can put our magnetic field vectors and our velocity vector tail to tail and see what angle that these two vectors make. Now we'll notice that the angle between the two is just 90 degrees. So we're going to plug that 90 degrees into our equation here. When we're done and we solve this out, we see that the magnitude of the force that this electron feels as it travels vertically through this horizontal magnetic field is about 5.4 times 10 to the negative 18 newtons. So something quite small, but remember, we're being asked for the acceleration due to this magnetic force. And from our Newton's laws, we remember that if we have a force, a net force being exerted on our particle, and only force existing really is this magnetic force we dealt with earlier, that is going to be equal to the mass of our electron times its acceleration due to this magnetic force. So we rearrange that, and we see the acceleration is given by the force, the magnetic force that the electron feels, divided by the electron's mass. So if we go in and write these out, the electron is experiencing a force of 4.5 times 10 to the negative 18 newtons. 18 newtons. And our mass of our electron is 9.1 times 10 to the negative 31 kilograms. Very small. In the end, we see the acceleration from the magnetic field acting on this electron as it moves vertically is about 5.9 times 10 to the 12 meters per second squared.